guys, GCF in this particular problem is, what's common to each term? 1x. So the first step is, and you have to show this step in your work, is to factor out an x and put a big set of parentheses enough for 3 terms. So what's left over if I take out an x from right here? X squared. What's left over if I take out an x from right here? 6x. What's left over if I take out an x from here? 5. All right. The x stays in front. That's the GCF. Now we factor how we factored the other day when we learned how to do this. So we do our 2 sets of parentheses, okay? These first 2 terms have to multiply to be x squared. So what do we put there? X times x. And the last 2 terms, they always have to multiply to be the last number and add to be the middle number. What's the only thing that multiplies to 5? 1 times 5. And those add to 6 as long as they are both positive, right? So plus 1 and plus 5. And that's our answer. Okay, so GCF, factor tractor. This is weird. It's freaking me out. That's on the other side. So is my scroll bar. All right, write that down. I don't know why my scroll bar went on the right-hand side. Okay, negative x squared minus x plus 42. Write that in your notes. If the first term is negative, you guys, it's really going to throw you off unless you factor out the negative. So in this case, the GCF is actually -1. We're just going to take out a -1 from the entire thing, okay? So if I factor out a -1 from all 3 terms, all that does is change the signs, right? So I'm taking a negative out from the x squared. That gives me positive x squared because it was negative. And then I'm taking a negative out also from the middle term. So what's that going to be? Plus x. And then I'm taking a negative out from this 42. What's that going to make this? A negative 42. Good. All right, the -1 stays in front. You don't actually have to put a 1. You can just put a negative sign. It's the same thing. All right, either way. Now we're looking for 2 numbers that multiply to be what? -42. And Riley, 2 numbers that add to be what? +1. Okay, so we're looking for 2 numbers that multiply to this and add to this. So for 42, we have 1 times 42, 2 times 21, 3 times 14. What else? 6 times 7. Which of those add or subtract to 1?
6 times 7.
Yeah, 6 times 7. They need to add to a +1, though. Add to a +1. Which one of these is negative? Good. So we need x minus 6 and x plus 7. That way they multiply to a -42 and add to a +1. And now we're done. You guys, these are 2-step problems. Do not do 1 step. I will mark you wrong. You must show this step here, where you factor out the GCF. Oh, wait, I think I skipped one. There's one more down here. This is the oh, there's 2 more. That's cool. All right, let's try 2 more. Oh, you guys okay? All right, here we go. -4x cubed minus 28x squared minus 48x. Okay, GCF first. GCF first. So, GCF. Biggest number that can factor out of all those is what? 4. Okay. What variable is common to all those? X. And there's a negative in front. Okay. If this first term here is negative, we need to factor out a negative. So we're actually going to factor out a -4x. That's our GCF. So -4x, and then we have to say what's left over. So if I take out a -4x from this, what's left? Yes, very good. X squared. I take out a -4x from this. Well, I took out a negative, so that's going to make this positive. 4 times what gives me 28. And I took out an x. So how many are left? 1 of them. Okay. Now I have this guy here. I take out the negative, so that's going to change this to a positive. And 4 times what gives me 48? 12. And I took out the x So there is no more x right here. Now it should look nice, okay? So my GCF stays in front, and now I have my two sets of parentheses. We need two numbers that multiply to 12 and add to 7. This one's easy. What is it? X plus 4 and x plus 3. All positives, okay? Add, multiply to positives. Let's do this one. It looks really fun. Write that down. 16a squared bx squared minus 48a squared bx minus 160a squared b. Once we do GCF, this problem will probably look really easy, right? It's really just the GCF that makes it look hard. Dylan, hurry up. Blow your nose harder. Let's go. Get it out. You're taking your time over there. We need you on this. All right, number. The biggest number that goes into 16, 48, and 160. Ella, what do you think? I'm with you. 16, okay? So we're going to factor out a 16 first. And how many a's are common to each one? Two of them. So we need a squared. How many b's are common? One. What about the x? Can we factor an x out? No, because this guy does not have any. So that's what we factor out. Then we need a big, I'm going to need more space. We're going to need to move this down here. Okay. So now what's left over? So I took out the 16. I took out the a squared. I took out the b. What's left in the first term? X squared. Okay. We have a minus sign, and we didn't take a minus out, so it's going to stay minus. Anyone know 16 times what is 48? 3. Very good. Okay, the a squared came out, the b came out, so what's left? X. Okay, minus 16 times what gives me 160? 10. And then a squared b all factored out. Now this looks really nice. Okay, so 16, a squared b stays in front, rewrite it. We have our two sets of parentheses, x and x. Okay, multiplies to negative 10, adds to negative 3. What do you guys think? Definitely 5 and 2. Okay, in order for them to add to negative 3, which one has to be negative? 5. Yes, and then multiplies also to a negative. And we got our final answer. But make sure you always show me the GCF step. That's really important, okay? These are two-step problems now. Subscripted variables, you guys. Basically, it's still just one variable. So let's say you're talking about two different areas. We can differentiate them by putting a little t or a little p next to them. So I might be saying area of a triangle or area of a parallelogram. That's all a subscripted variable is. Okay, so it's just like a variable, and it's only one variable. It's not two. All right. So here's a problem you might see right here that has subscripted variables. It looks really hard, but it's not. You guys can actually just change them if you want to q's and n's. Notice how I did that? I rewrote the exact same problem right here, but instead of nq, I just use q. And instead of nn, I just use n to differentiate them. So I use just the subscript. And then it's a really easy problem. So if you would like, you can change the subscripted variables. You could also just solve this problem right here with the subscript. So I could times everything by 6. Okay, I could do elimination right here. Add them together, and I'd get 30 NQ right here. And I just leave it as NQ. Those would cancel. I'd add these here. I'd get 390. Okay, and I would divide by 30 like we always do. And NQ would be 13, right? That's all it is. So if you want to do it with the subscripts, that's fine. If you want to just change them to q's and n's, that's fine. Everybody good with this? Okay, I went pretty fast, but you already know how to do that. So let's try a couple factor tractor problems.